All right, hello. We're going to start today with similar polygons. Now, there's a couple of things as we get started that you want to recognize. The difference between similar and congruent. All right, so congruent was the same shape and the same size. We've already talked about that in class. Similar is when they have the same shape, but they have a different size. So they're changing size, but it has to change in a specific way. And it needs two things. The corresponding angles have to be congruent, and the corresponding sides are proportional. And this ratio that the sides have is called the scale factor. So if polygons are similar, then their perimeters are also proportional. So their sides will be proportional and their perimeters. So you should stop the video right now and go ahead and get this copied into your notes. All right, so if you're back, the other thing we're going to talk about here is scale factor. Now, order matters in the scale factor. Just like in the dilation, the order mattered. You always use the image versus the pre-image. We're not dilating now, so now the way you know how to write your scale factor is based strictly on the information they're asking you to give. So if we want a scale factor of ABC to DEF, we take the side from ABC, and then we take the corresponding side from DEF. So AB would correspond to DE, and so we write 8 to 12. Now, of course, that can be simplified by divide by 4, and you get 2 to 3. Now, if they're asking for the scale factor going from DEF to ABC, you're going to write that a different way, because DEF is first, so 12 to 8. It will still simplify the same, and it will be 3 to 2. And then, like we said above, the perimeters are also the proportional, and they're the same proportion as the sides. So if they're asking for the perimeters of DEF to ABC, we would again write that as 3 to 2. So be sure and understand that the order matters in scale factors, and that you want to get the relationship between the two objects in the same location. So if you need to stop and pause to add this information in, go ahead and do so. And now you should be moving on, and we have the similarity statement. So there's a symbol for when things are similar, and that's just a squiggle. Okay? And a valid similarity statement must match corresponding angles and sides. Write a similarity for the one above. So you have to go in the same order. You're going to go A, B, C. That's your triangle. A, B, C is similar. And then you look and you match these same angles. A is the same as D. B is the same as E. And C is the same as F. So you're going to write it in that same order. D, triangle, D, E, F. If you don't write it in the correct order, it's not considered a valid similarity statement. All right, so let's look at the ones below. We'll do the first one together, and then you can do the next one on your own. This up. There we go. All right, so we've got these two triangles, JKL. So JKL and PMN. So what I'm going to look at doing is I'm going to put these just like those are above shown, J and then 2 for K and 3 for L. And then I'm going to go to this one, and P is going to have the 1, M is going to have 2, N is going to have 3. Okay? So when you look at this, you're going to say angle J is congruent, because the angles have to be congruent to angle P. And angle K is congruent to angle M. And angle L is congruent to angle N. So you notice that we've matched these up. This has 1 arc, and P has 1 arc, and J and P are congruent. K has 2 arcs. Whoops, sorry. K has 2 arcs, and M has 2 arcs. L has 3 arcs, and N has 3 arcs, and L and N are congruent. Then we also have to look at the sides. Remember, the sides are not congruent, they're proportional. So you can go JK to PM. We're looking right up here. To PM is equal to, and the next one would be KL to MN, and the last one would be JL to PN. Now these are the same sides as they go around on both locations. I look at it this way and I just write it like this. JKL, PMN, JK, see that right there? PM. And then you've got KL, MN. Okay? And then it's the first and the last. First and the last. So if you're having trouble writing those out, that's a good way to do it. You can do this one. The only thing I will tell you on this one, just as a little bit of a hint, be sure and look at where your triangles are, because you have one overall triangle and then you have another smaller triangle. Okay? So make sure that you write what angles are congruent and what sides. Alright, let's look at the back. And this would be another one, same thing, only now we have a polygon, a quadrilateral actually. But you're going to do it the exact same way. Similar figures are similar figures. You're just going to have 4 angles instead of 3. Okay? Now let's look at number 4 here. We'll do one of these, 1 or 2 of these, and then you guys can work on these. In this figure, they're giving you the scale factor. All right, it's 2 to 3. And it tells you that find the x. So in the figures below, they don't tell us which is which, but because we can say that we're going to go this one to this one, 2 to 3, left to right, okay? So we're going to do that, and it'll be 2 over 3, okay? And then this would be the 42 over x. All right, we're going in the same order. We're saying this is 2, this is 3, this is smaller, this is bigger. And then we say this size to that side, because they are the corresponding sides. And then you do your cross multiply, divide by 2, and x equals, that's 21, so 3 times 21 is 63. That would be our answer, okay? So you can do number 5. And again, it's 6 to 5, so this would be the first one, and this would be the second one. This one, they give you the proportion, so we'll do one like that, and then you can finish these out. So in this case, they give you the proportions. You know you want to find x. So the first thing to do is see which of the sides over here relates to DE. Okay. So DE is right here, and that relates to AB. So AB to DE is going to be equal to, and then we can use EF, which would be BC. That would be a good one. BC to EF. Now you notice, if I put AB on top here, I have to put and DE on bottom, then I'm going to again put AB on top, or this triangle on top, and this triangle on bottom. Remember, order matters. You must keep the corresponding ones in the same location. So if we do that, we're going to have 25 over x equals 20. We would just cross multiply again. 28 times 25 equals 20 times x. So 20, this is 700. And so x equals 35. All right. So that's how you would do that. So what I want you to do is to do the first part we had here. Make sure you have all your notes, and then you're going to finish number 2. And then you're going to finish number 3 here. And then we did 4 and 6, so you need to do 5, 7, 8, and 9. Now 8 and 9 are the same. You are going to have some algebraic expressions to solve, but you've done some of those already, so you should be good with those. We'll see how you do. Okay, when you're finished, be sure and snapshot this and submit it to Google Classroom. Thank you and have a good day. See you in class.